Okay, so the homework is in Blackboard, and you can see it says week 1 here, week 2, week 3, all the way up to week there. Okay, and also the PowerPoint are given here, so if you want to get them, you can just go like that. That will take you here. And these are all the PowerPoints. Okay, and we're going to do lecture 2 today, and there are some images and so on for lectures 12 and 14. Okay, and going back to Blackboard, the other thing is that if you have questions, I want you to do it in a 2-step process. So the first step would be to enter it into the discussion area. So we have a discussion here, and we have just questions here. And you can create a thread, and then ask your question. And at the same time, if you're afraid that no one's going to see your question, you can email the TAs and tell them that you entered a question here, and they're going to try and answer it. If they can't answer it, then then they'll contact me. Okay, so that's the way I'd like it to happen. So it's under here, under discussions. Okay, and if you go back to the home page, you have the contacts for the TAs here. Okay, so you can contact the TAs here. Okay? So does everyone follow that? Okay. Then also, yeah, that's all. Okay. So let's, so if you had trouble uploading your homework last time, that's okay. You can do it late this week. Well, since it was the first week, not everybody knew how to do it. But anyway, this is where you should. This is where you should upload your homework. So here you go here, and you should be able to upload here. Actually, I'm not uploading because I'm the instructor, so it doesn't give me that kind of interface. But it should for you, and the same thing here if you click on here. Okay? So you should have a place to upload your homework. Did everyone get that? Any questions about that? Okay, if you do have, yes.
Oh, sorry, sir. Will the homework grade, will the homework, if we submit the homework, will score will eventually go up?
Yeah, you'll see a grade for it eventually, not automatically, but eventually. Yes? Somebody else have a question? Yeah, so we'll grade it. I'll grade it.
Oh, but you graded the homework before?
I haven't graded it. We haven't graded everything yet. Okay. So anyway, as I said, if you didn't hand it in here yet, you can do it still for week 1. We won't count it as late because this is the first week. So I don't expect you to get it. I didn't explain it that clearly before. Okay, any questions? Okay, so then let's go to lecture 2. So before we go to lecture 2, why don't you open Visual Studio, Microsoft Visual Studio. Everyone should open that here. Okay, so you should have this interface, right? Okay, while you're opening that, let's go to the PowerPoint. Just here. Lecture 2. And let's look at the program that you're going to build today. So if I go down to here, you'll see the program that you're going to build today. Okay, so what is it? What does this do? what do you think this does? This is a clock, right? And it has the current time here, and it has the current date here. Okay, and it runs when you click this, or I mean, it displays like this when you click confirm. Okay, so you're going to build that, and then you're going to build one more program after that, actually. Maybe I'll share the second one as well. So you're going to build a slot machine, something like this, and these, when you open this program, these will be flashing different numbers, and then you'll click catch, and that will stop it, and hopefully the idea is that you get some matches here, and then if you do get the matches, then this image displays, and it also makes a little beep. Okay, but if otherwise this image is not showing. Okay, so we want this image to be invisible at the beginning and only to show when there's some matches here. So let's see if we have big film. So here, so if it's 1, 1, then this shows. And then there's also this. Actually, I don't think we're going to program this in today. This is a little tricky because this has to, like, when you play it again, this has to remember whether you won or not, and keep a record of it. And that is a little bit trickier than it might sound. Not really tricky, but it just takes stuff. Not completely straightforward. So anyway, we're going to try and build both of these programs. Anyway, that's going to be, whatever we don't finish is going to be your homework for next week. Okay? So by the way, if you were just going to, if I asked you to build a clock, first of all, I don't know if you would design it just like this or not, but you might, if you're a programmer and you're working for a company and they say, oh, we want you to do something, you're going to have to design it yourself. You're going to have to design it in conjunction with the people who ask you to do it, right? And you'll say, oh, how about this design? And they'll say, no, change it to this. And anyway, so there are lots of different designs you could come up with, right? This is one simple design. So actually what I want you to do is build this form right now. Now, if I ask you just one thing though to make clear, and that is what do we have on here? What does this form contain? What do you think? Maybe you're not sure, but what do you think? Anybody want to make guesses about what's on here? Yeah, but I mean, in terms of controls that you have to add to the form, what do you think? What controls are there here? Have 2 buttons, and the rest are actually labels. Okay, it doesn't exactly. Maybe it's not 100% sure that this is a label, but this is a label. These are both labels. Okay, with that, please build the form, not the program, just the form. Okay, and call it, by the way, simple clock, one word. Simple clock, one word. Okay, so no space between simple and clock. Okay, so you know that you have to do that here, right? Simple clock like that. And I'll pause this video while you're beginning to build it. So it would look like this. Now, you want to get this toolbox in there. So you click here, and then pin it up here. And then you might use comment controls here to see the comment controls. And the properties window is here. Okay, so I'll just make it bigger, but you don't have to do that. And then you would put, you could just double click here, label, 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 you get 4 of them. And double click button, button. You get 2 of those. Okay? So that sounds like a reasonable design. Okay? Alright. So now you have the design. And you might want to give it a name. How do you give this, how do you give this a name? You click on the form itself once, and then you go to name, not name, sorry, text. You go to text, and I think he called it simple clock or something like that. And then that shows up here, right? Okay, let's go back to the screen, the PowerPoint. And of course we want to remember what I said before. I said if I'm wearing a sweater and it says APU on it, right? So that's the text, that's my text property, right? But that's different than who I am. Okay, so I have a text property and I have me, right? So me, I'm Cluster, but the text property says APU, right? So same thing with these labels. They have a name and a text property. Those are different, can be different. They don't have to be the same. Okay, so we want to give our labels some names. Now I think he doesn't worry about this one. I think he doesn't worry about this one or this one, the names. Of course, the text properties he does worry about. But here, he says the name should be something, and here he says the name should be something. And so why don't you change these first? So give them name of LBL time and name of LBL date. And you can also change the text to equal question mark and question mark. Now, can anybody think of a reason why we don't really care if we label these two, but we do care if we label these two? Can anybody think of a reason why we don't really care about labeling these two?
Because we're not gonna change the property.
Right, because in our program, probably we're not going to change these at all, right? Those are just going to sit there, right? So we don't need to refer to them in our program, right? Does everyone understand? So therefore, but these we are going to refer to, so we may as well make some convenient or informative labels for them, and that's what we did. Why did we call this LBL? Because it's a label. And why did we call it time? Because it's a label about the time. Okay, and so on. Okay, so then can you also fix these two as well, the two buttons? Okay, so give them names as well. Okay, so you give these two the names. Why do we call this one BTN? To let us know that it's a button when we're using that name, right? It's much more convenient than if you just call it exit. You might not know that that's a button. So we call it BTN exit and BTN confirm. Okay, everyone get this? Okay, let's go on. All right, now you've made the form. By the way, why don't you run the form and see what happens? So when you run it, you're going to see that nothing happens, right? So we need to change that. We need to make something happen. So when do we want something to happen? When we click the confirm button. Maybe that's not clear, but that's what we want, right? We want it to happen when we click the confirm button. So we want some code to happen, to run, when we click the confirm button. Therefore, where should we put the code that we have to write? Underneath the confirm button, right? In other words, you should double click the confirm button, and then Visual Studio will generate this thing up here, this line here. It says private sub but VPN confirm underscore click, blah, 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 and then end stop here. Okay, it will generate that for you, right? Everyone agree? Okay, so then we're going to want to put our code, whatever we need to do, whatever we want to happen, we're going to put our code in there. Now we could make anything happen, right? We could make the whole program crash, or anything we want, we could put in there. But of course, we don't want to just do that. We want to put something. We want something specific to happen. So we want to put the code for that specific thing to happen. So what specifically do we want to do? Well, what was the name of this label? LBL time, and what was the name of this one? LBL date. Okay, so what we want is to fill something into those labels, right? In fact, we want to fill in the we want to change the text property of those objects, right? So we should refer to the text property of those objects, or we're going to have to refer to the text properties of those objects. So the LBL time is the name of the object, and if you want to refer to its text property, the way you do it is with the so-called dot notation. So you say the object name, and then the property you want, separating them with a what? You put the object name and the property, and you separate those two by a what? By a dot, or a period. Okay? That's the syntax of Visual Basic. That's how you access properties of objects in Visual Basic, or how you access properties of controls in Visual Basic. Remember, these are controls, right? We call them controls. Why did we call them controls, by the way? I'm asking you that again for two reasons. One is because I want you to remember, and the other is I want to enter it into this video. So why did we call them controls? Because they allow the user to control which part of the program should run. Okay? So if you have lots of different parts of the program, you let the user control which part, so we call them controls. Okay, anyway, this is a control, this is a control, they're all controls actually. Okay, so how do we, again, LBL time dot text, that's the control and the property of that control that we want to access, and we have to separate it with a dot. Okay? Now, instead of doing the complicated thing that he has here, just type LBL time.text equals now. Just type that and see what you get. I'm sorry, and just type that. So LBL time.text equals now. Just do that. And then let's see what you get. So I'm going to spy on you because I'm not running my own. So I need to look at somebody. So I'm going to spy on you and choose somebody who's got it working. Okay? So is that, who has it working? You have it working. What's your, by the way, your computer number is written on the top of your computer, so you can look at on the top of the hardware up here, and it says like this one, there's 1 or something. You can look up here, right here, on the top. So what's your computer number, the person who raised their hand? That they did it? It's right where your headphone is. Now, up here, up, look down. No, hello? Right here. What is it, 31? Okay. Sorry about that. It's a little hard to show that. Okay, can I look at yours? So if I look at yours, okay, so you see he did it, and look what he has there. When he clicked confirm, maybe I think I can actually click confirm here. Yeah. Okay, you see what happened? So he gets all of this there. Okay, that's not exactly what they asked us to do, is it? What they asked us to do is this, right? This is a little different than what he got. Do you see the difference? We get just the time here, but what I asked you to do generates what? Not just the time, but also the date here, right? Understand? So what did we use to do that? Can I exit your program? No. Yes. So what did we use to do that? We used now. Right? Do you see that now? So all we did was we filled in LVL time.text equal to what? To now. So now is a special word in Visual Basic or in VB.net that generates this string, that you just saw, right? It generates this. Okay, is everyone following me? Everyone following me? Okay, so one thing is, remember in this, if you watched last week's videos, which I asked you to do, I said, well, there might be a quiz on it. I talked about high-level language and machine-level language. So what do we mean by machine-level language?
It's a language that only the computer can understand,
Right.
which is 0 and 1.
Yeah, he said it's a language that only the computer can understand. Well, no, a human can understand it if you're really smart.
Yeah.
But the computer can only understand that language. Or maybe that's what he meant, sorry. So computers can only understand zeros and ones. So if you want to really speak directly to the computer, you have to type in some program that just consists of zeros and ones. Now that obviously is not what we want to have to do. So after the machine language, they have something called assembly language, and after that, they have high-level language. And high-level language allows you to write kind of like an English-based command, which will then be translated into zeros and ones, and the computer will do it. Okay? So that's like the word now. Obviously the word now, we pretty much can understand what that means. That's kind of almost English. It is English. And we can, it's pretty clear what it means. And so there's a special word in the VB.net language called now, and we call those special words, they're called keywords, or they're called reserved words, or special words. And there's one called now, and that's part of the high-level language, and that will generate this whole string. Okay? Now, but that's not exactly what we want. Our company gave us a different set of instructions to do. They don't want that. They don't want that. Okay? They want us to do this. So we have to fix it. Right? We have to fix it so that it doesn't look like that whole long string there. Okay, so the question is, how do we fix it? Okay, so how do we fix it? Okay? Now, let me write it here. I would usually do this on the board, but since I'm trying to record this, I'll do it here. I'll make a new slide, and I hate that color in the background, but okay, what's that called in math? It's a function, right? Right? Do you remember that in math? F of x equals 5x, or something like that, right? You know that? Everybody knows that, right? So we say that's a function, and the variable is what in this function? What's the variable in this function? X, right? X is the input, X is the variable, right? Okay. Now, sometimes they use this word for the variable. They use this. Okay, I don't know why they use that instead of variable, but sometimes they call it the argument. So somebody probably gave it this name, and he was important, and so he or she was important, so they kept that name, even though it doesn't really, there are better names that we could use. So anyway, they call it the argument for the function. Okay, so instead of calling it the variable for the function, they call it the argument. Now, if I wanted to, I could also do this. right? You could do that. So in the first one, if I put x equals 2 in here, what do I get? I get 10, right? And in this one, if I put in x equals 2 and y equals 3, what do I get? We get 2 times, that's 8, and 3 times is just 24, right? So I get what? 32, right? Okay? So you can make a function with as many variables as you want, right? I could keep adding more variables and make a longer string here, and so what, right? It doesn't matter, right? So you can have a function with as many variables as you want, right? Everyone agree with that? So, in programming, we also want to have functions. So let's go back. Okay. So we want to put, again, where are we? We're trying to put some code in here, right? And we said we're going to use LDL time.text to access the text property of this label over here, right? And then we said we could use the keyword now, but it's not quite in the form that we want, right? So we want to modify it a little bit, okay? And so now we're going to use a function to do that. Now we're going to use a function to do that. So let's read about functions. So what does this say? Many functions are used in Visual Basic or in VB. Okay, now he mentions 2 types of functions here. So what's the first type? User-defined functions. That's functions that you will write yourself. Okay, but before we learn how to write our functions ourselves, let's just learn how to use a few that are already written. Okay? There are built-in functions, functions that are already written, and they're stored in like folders, which they call libraries. Okay? So it's just a folder, basically. Okay? So 3 useful built-in functions are, there's one called time value. So remember that when we have, if I ask you going all the way back to here, I say, what's the name of this function? What's the name of this function? F, right? Same thing here. What's the name of this function? F, right? So in the same way, I can ask you, what is the name of this function? And it's time value, right? So whatever precedes the open bracket is the name, right? So you can call it F, you can call it G, you can call it time value. Call it anything you want. Okay, it's called time value. And then you have the brackets. And this is the argument. Now, you know, we could call the argument anything we want. We could call it X, we could call it Y, we could call it Z, we could call it anything. We could call it string if we want. Right? Does everyone agree? So that's all it is. It's just the name of, it's just a temporary name for the argument. Okay? Now, he uses, and it's not completely arbitrary that he uses the word string. He's trying to tell us, in addition to the name of it, he's trying to tell us a little clue about what kind of thing it has to be. So, it has to be a string. Now, I'll write this on the board because I don't want to have to type anymore. But suppose we had this function. Okay, that's a function, right? The square root of x. So there are certain restrictions on the kinds of things we can put into that function, right? The square root of x. What do I mean by that? We're not supposed to put what, generally speaking? Negative numbers, right? We're not supposed to put negative numbers into that, right? There are some restrictions on the kind of thing that a function can accept, right? And the same thing here. There are some restrictions on the kind of thing the time value can accept. So you're not supposed to put a number into this function. It'll cough. It'll have indigestion. It won't work, right? It doesn't know what to do with a number. It's just not built for that. But it is built for strings. Okay, so actually that now function that we saw, or the now keyword that we saw, generates a string. Maybe you don't recognize it as a string. Maybe you thought it was a time. But it actually is a string. It's actually just text. Okay, so now generates a string, so it's okay to put now into time value. Okay, just like it's okay to put a positive number into here. Okay, in the same way. All right, does everyone get it? So functions can, have are who makes these functions? Anybody, some part of the Microsoft team makes these functions, right? And they make them the way they want, and they built this function to work in a certain way, and they expect that you're going to put a string in there. Okay, so if you don't, it doesn't work. Okay, so so now readjust your program so that it looks like this, and see if it works. And I'll try to. Did I turn off the sound? Do all this very quickly because I forgot to turn on the speaker. I'm recording. So I was saying that we have functions like this. What's the name of this function? F. And this is called the variable, but we often call it an argument. And this function has more than one argument, but that's fine. We don't have any issue with having more than one argument. And then I said that we need to add some, we saw that we did this with just now, and that was okay, but it didn't do exactly what we wanted because we don't want that whole long string. So we need to somehow clean it up. And we talked about the fact that there are, we can use functions in programming as well. And there are many functions used in Visual Basic, and we can divide those into user-defined functions, which means functions that you actually write yourself. But before we do that, let's learn about functions in general. And we talked about built-in functions as well, that are just basically functions that have been written by somebody on the Microsoft team. And two examples of that are the time value function and the date value function. And I said that just like if you consider the function f of x equals the square root of x, the square root of x function, we know that there are certain restrictions for that function. I mean that there are certain things we can put in there and certain things we can't. And specifically, we say that we're not allowed to put in negative numbers. So I can't put in -4 into the square root function. And in the same way, these functions, like the time value function and the date value function, are also have some restrictions, and the name of the argument for this function, it could be anything, it doesn't matter what we call it, so we could call it x, we could call it y, we could call it z, but he happens to call it string, but he doesn't do that for just no reason. He's doing that to give us a hint, which is that the input to this function should be a string, just like we said the square root function. The input should not be a negative number. The input should not be something other than a string here. Okay, so then I ask you to fix your program. So hopefully you fixed it. Okay? Does it run now the way it's supposed to? Okay? So now you've done it, yes?
So there's now, and it says now as a built-in property. So it's one of the functions and the user-defined functions and built-in functions.
Where does it say now? Now.
Oh yeah.
Now is a built-in property that gets the current system time and date. Yeah.
It connects the current time that is already in the computer.
Yeah, actually what it does is it reads the time on your computer. It doesn't get it from the internet or something like that. It just reads it from your computer.
It's one of the functions, the built-in functions in the library.
Yes, right. Although, generally speaking, when you write functions, you should have parentheses at the end of them. But Visual Studio allows you not, Visual VB.net allows you to be sloppy and not have those parentheses at the end. In other words, usually you should write, it would look like this. Like that. But Visual VB.net allows you to be sloppy under certain circumstances and not have to write those properties. I forget when it is. You can look it up on the internet. There are certain times when you don't have to write these. But that's actually, I don't like that because it's confusing. Like, you don't even know that it's a function if you don't put brackets next to it. Yes?
So my question is, there are two types of functions are used in Visual Basic.
Right.
And one is user-defined function,
Right.
which is we make the function.
Right, that's right.
And the built-in functions is such as now.
That's right, such as now. And such as time value, and such as date value. These are all built in, right? I mean, right? We didn't write these, right? We're using them, but we didn't write them. And same with now, we didn't write how it works, we're just using it. Okay? You'll see later that you can actually write functions yourself. You could call that function like square root plus 3 or something. And you could write a function that does square root plus 3. And, okay, anyway, we'll see that later. Okay, does it work? And the exit function, how do you get that to work? You just put end here, E-N-D, right? Okay, everyone get it? Okay, so now, supposedly it runs. Let's read his kind of complicated computer scientese type of description of what we've done. So this is kind of from a more abstract description or from an abstract perspective of what we're doing. So, you know, you're just learning a little bit about programming, but if you really wanted to learn a lot, you'd have to learn sort of the computer science of, you have to learn the science of computer science, right? You'd have to study a lot of programming courses, and you'd start to talk like this, actually, if you did that. So our program behaves as a very simple automaton or robot. It initializes once. Okay, that's not very clear what that means, right? But it initializes once, then enters a waiting state. So this is very kind of from some weird perspective that you learn later. Upon input, the input is a click event. It waits and executes the corresponding code once, then returns to the waiting state. So in other words, you click it, it does something, and then it stops doing something. So this is kind of a weird way to describe everything. But if you look up in Wikipedia, automaton, you'll see a kind of discussion of that, and then you can put what we've done into that framework. Okay, so if you want to do that, you can. Okay, now, formatting the displayed time. So you can use, you can do this. So remember we said that a function can take more than one argument, right? Remember we said a function can take more than one argument. I said here. There, right? This function takes how many arguments? 2, right? So in the same way, some programming functions take more than one argument. And now we're going to do the same thing that we did here, but we're going to do it with a different function. What function did we use before here?
We did a built-in function.
Yeah, it was a built-in function, but what was it called? What was the name of it? No, time. Now was in here, but this on the outside was what? It was time value. I'm sorry, I didn't even recognize. It's actually here. So we're still using time value, but we're taking the result of that. So this, do you recognize that we just had this before? We just had time value now. What we're doing that now is we're putting this inside this. Okay, so the result that is generated from this function is now becoming an argument for this function. Right? Do you understand?
Yes.
And then, and what's the name of this function, the outside function? Called format, right? But how many arguments does format take? 2, right? How do you know it's 2? How many commas are there?
1.
There's 1 comma here. So how many arguments are there? There's 1 to the left of the comma and 1 to the right of the comma. Okay? So format takes 2 arguments. One of the arguments is what? The time value now, whatever came out of that, which we already saw what came out of that. Okay? And then the other argument is this thing which is in red. Right? Do you understand? So it takes 2 arguments. Now, the thing in red allows you to format the result. So you can format it so that you have the hours, then the minutes, then the seconds, and I guess TT gives you PM or something like that. PM to AM. Okay? Did you understand that? Now look what you can do here if you wanted to. You could format it this way. You could format it as HH this character, MM this character, SS this character, and then TT, right? And what would that look like? That would look like this. So in other words, it allows you to format whatever you put in here. Okay, is that clear? Now, let's just look at the options that you have for formatting. These. Okay, so you can use HH. What does the HH do? It gives it to you in the 12-hour system. What does H give you? It gives you in the 24-hour system. I'm sorry, capital H. What does capital HH give you? 2 digits in the 24-hour system. I don't know exactly what the difference is between this one and this one. And what about M and MM? I'm not sure what the difference is there. 2 digits. What's the difference between 1 and 2 digits? Oh, I guess if the number is, if it's a 3, it'll be 0, 3 here, and it'll just be 3 here. Okay? All right? So you can play with the formatting using these different symbols. Right? So if you wanted it to be 24-hour, you could use this or this. Right? Is that clear? Okay, so you can do it like this, or we said you can do it like this, and so on. Yes, question?
So we put the another format, then the other type of functions. So will this be a user-defined function?
No, it's not a user-defined function. We won't make any user-defined functions for a while. So we're just using functions that have already been built. So if you want to make a user-defined function, you start out with, I think, the keyword function, and then you write some code inside, and so on. It's different. Okay? Any other questions? Okay, what does he say down here? We could improve our program further if we like. We could format the date as well. And we could add a timer to automate the update. Okay? So we'll discuss timers next. Okay, any questions so far? Okay, so you built the first program. Now we won't have a chance to finish this one, but we'll start. And there are some videos about this in on YouTube, in my YouTube channel. Okay, any questions? Okay, let's make our slot machine, which is going to basically look like that. So what do we need here? You want to make a slot machine, what do we need? What? What controls do we need? What?
We need the 3 buttons.
We need the 3 buttons,
5
right?
labels.
What?
5 labels.
And it looks like 5 labels, but actually the bottom one, this thing will not be a label. This is a picture box, I think it's called. Anyway, it's not a label, it's something else. Okay? So how many labels will we need? 3 plus 1, 4. this is a label, this is, and this is also a label. Okay, so we're going to need 4 labels, 3 buttons, and then this thing which we'll program in later, we'll put in later. So make that form if you want to save yourself some work. You can save what you just did, because you will need to hand that in, or you can redo it again. It's not too much work to do it again. Your choice. And then start a new one, and we want to call it, I think, just slot machine. Okay, just call it slot machine, and make the form, please, now. So someone asked whether so when you save the project, if you don't save it, all your work won't be in the folder, but once you save it, all the current work will be in your project folder. In this case, the project folder was called Simple Clock. And then he asked, what should you submit? So I think we're going to switch to, for now, that you only have to submit the executable file. So let's see if I can find that in my system, just to show you what I mean. So you go to My Documents, right? And then you go to this one, Visual Studio 12. Then you go to Projects and Simple Clock. And then to find the executable, you go further into Simple Clock again, and then Bin and Debug. And here's the executable. So you can run this executable, and that's just like a regular function, a regular program that you would run on your computer. Of course, it doesn't do anything. Now, so I'm going to say that you only have to submit this for the next homework. Now, that's not general policy, but for the next homework, you only have to submit the executable. Now, you should be careful sometimes when you send the executable by email, the email will reject it, because executables can be dangerous. So you should never run an executable file that you get through email or something like that, unless you absolutely know what it is and who it came from. Because the executable file basically can do anything on your computer.
How would you know that the person?
Well, I don't know, but I'm just saying, that's the problem, right? So, because it can do virtually anything on your computer. So anyway, but for our purposes, this time you can submit just the executable files, so 2 of them for next week. Okay? Just for next week.
Also, I have another question.
Yes.
Will exe file, executable file, will still run even though we don't have the visual?
Yes, it should run as just a regular program. Any computer. I hope.
Just exe file itself.
Yes.
Right. That was my question.
Now, by the way, one other thing. If you're using the free version of Visual Studio, if you didn't get the one from there, then you can't make an executable file. In that case, you have to send the whole folder. Okay, because that's the restriction on the free one, that they don't allow you to make executable files. Okay? So in that case, you have to send the whole, everything, the whole project, zipped. Okay?
When I first submit the homework, I put the executable file at the outside of the box and the program file.
Okay, that's okay. Good. So you should look for the executable file, which is in here, projects, your debug. You can look for the executable file, and you can run that by itself, and you can also send it to somebody else. Again, you should be careful when you open an executable file. You have to know exactly who sent it and where it came from, and so on. Otherwise, it's very dangerous to open it. And but for our homework this time, you can send just the executable file. But if you only have the free version of Visual Studio, then you won't be able to generate an executable file. In which case, you have to send the whole folder, the whole project folder zipped. Okay, let's go back to here, and you're supposed to make this form. Right? Okay, so I'll assume that you got this far. And now you want to change the colors and so on. But right now, let's not get stuck in that. I'll ask you to do that later. Okay, but you can change the colors by changing here the background color to light coral, to yellow, and to deep sky blue. So you can just use those keywords. Again, high-level language. High-level language lets you use these keywords. There are other ways to do it. You could use some numbers that will generate these colors. But high-level language lets you use light coral, yellow, and deep sky blue, right, as as part of your code. Okay, and then they tell you to make the font 48 and so on. Okay, let's just leave it blank for now. I don't think we need to fill it in right now. So let's just leave it blank for now. Okay, you can fix that later. Okay, now here's the next concept. All right, so this is an important concept. I'll probably repeat something similar many times, but please pay attention. Okay, now if you go back to the code and you look at, is this still running or not? Let's see if it's stopped. Yeah, it's still running. Okay. Oh, here. If you go and look at the code that we had, how about here? If we go back to here. Here. Okay, ready? Pay attention. When does the code get run? When does this code get run? When does this code get run? When the user clicks on this button, right? Okay. So in the language of programming, we say when the user clicks the button, an event has occurred. We call that event a click event because obviously it occurred when they clicked. Okay? In fact, we call it a button click event. Why? Because it occurred when the user clicked the button. Okay? So it's called a button click event. But anyway, it's called an event. Okay? Now, in the language of programming, an event occurs and then some code will run, right? That's the idea. Right? An event occurs, but then we want something to happen, right? The code that happens is called the event handler. The event handler. That's a very important word. Okay? The code that runs is called the event handler. So what's the event handler in this screen? What's the event handler for the click event? So it's the code that will run when we click the button. So what is it? LBL time.text equals blah, 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 and LBL date.text equals blah, 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 right? That's called what again? The event handler. And why? Because when the event happens, that's how we handle it. Okay? So that's the very important concept in programming. Now, the kind of programming you're learning about is a new style of programming. It's called object-oriented programming. And that's where these concepts are used in object-oriented programming. Now, before object-oriented programming, there was other kind of programming. There were no objects and you didn't really have any screen. You know, I'm sure if you saw in the movies like 30 years ago, you saw people doing programs where, you know, it's just like just a black and white screen or something like that, right? There was no form or anything like that. But after that, they developed this so-called object-oriented programming. By the way, the symbol for that is, what are the initials for object-oriented programming? OOP, right? So it's called OOP. So you can see that on the internet. OOP means object-oriented programming. Anyway, so in this object-oriented programming framework or way of thinking, we have events, and the events occur, and then we want to do what with the events? What's the word? Begins with an H. Handle the events, right? We want to handle the events, and so we have an event handler. Okay? So what's, again, once more, what's the event handler here?
IBL time, blah, blah.
Yeah, LBL time.text equals something, LBL. Okay, or we could say that this is actually like a function, actually, or it's called a subroutine. But this whole subroutine, which starts here at sub and ends here at sub, that whole subroutine is the event handler. Okay, or you could just say the stuff inside is the event handler. I don't know if it makes a difference. Okay, but we have an event handler, okay? And what's the event that causes this event handler to run? The user clicking the button. Therefore, the name of this is nicely named as btn confirm _click, because it happens like that. So Visual Studio will nicely name it for you. Okay? All right? Everyone get it? Okay. So, once more, I'll repeat it again. What's the event here? Clicking the button, right? And then we have an event handler, right? Okay, good. Now, we're going to learn about another control, a special control, called a timer. Now, this is a very special control because it generates events by itself. Not when the user does something, it just generates events. And it generates an event you can have it happen 10 times a second, or 100 times a second, or every second, or every half, whatever you want. It can generate an event. And the name of the events, the name they give these events, are called ticks, just like ticks on the clock, right? So it generates tick events without the user doing anything. Okay? So once we get this into our form, it's going to automatically be generating all kinds of events. Now it can generate hundreds of events. If you don't have any handler for it, nothing's going to happen special. But if you have something that will react to it, if you if you write an event handler for that tick, then every time the tick happens, something will happen. If you don't write an event handler, then it doesn't matter. It'll just keep generating these events, but nothing will happen. Okay? But of course, we want to. We wouldn't put it on there if we didn't want to generate events from it, or handle those events, I should say. So we're going to generate all these ticks. In fact, we're going to get a tick every 10th of a second. In other words, 10 ticks per second. Okay? So we're going to generate these events, 10 of them every second. So what do you think we want to do when these events occur? What kind of event handler should we write? What do you think we want to do when these events occur? Why are we doing this? Why do you think I'm doing this? Any idea? Well, what do we want this program to do? It's a game, right? And what's the game? It's like a slot machine, right? In a slot machine, usually you see those things spinning, right? Well, we can't really make anything like that. They're not going to spin. But we can make it look like it's spinning by doing what? By changing the numbers quickly, right? So if you change all those numbers, like it's changing it 3, 2, 2, 2, 5, 5, 5, and the other one is changing 2, 8, 8, 8, 8, right? And so on. It's going to look like it's spinning right anyway. Whoever looks at it will get the idea, right? Okay. So what do we want to do? We want to get these things, the numbers here, to change quickly. Okay, so we're going to import this timer into our program. It's going to generate, what did I call them? What kind of events? Tick events. How many tick events per second? We can set it as we want, but we're going to set it to be 10 per second. And then, as I said, if we don't write any event handlers for it, then it doesn't matter. It can generate all these events, but nothing will happen. But what are we going to do? Every time the event handler we're going to write, we only have to write one, and it'll handle all the tick events. And so what do we want to happen in that event handler? In the tick event handler? To generate random numbers, actually, is all we want to do. We want to generate random numbers in each label. So we're going to have 3 lines, one for the first label, one for the second label, and one for the third label in the event handler. And then it'll work. Okay? So that's the idea. Now, let me just quickly remind you of something in Excel. I don't know if you've ever used this in Excel, but let me do that. If I type that in Excel, do you know what that does? It generates a random number between 0 and 1. If I copy it, different random numbers. Okay? And if I do this, so this first one over here generated random numbers between 0 and 1. So this part will do that, generate a random number between 0 and 1. And then if I multiply that random number by 10, I'll be generating a random number between 0 and 10. Right? So I'll get like that, and like that. Okay? Everyone understand? Okay, so that's in Excel. You can do that. Now, in Visual Basic, it's just a slightly different word. But let's take a look. Here. You see it? It's not RAND, it's RND. Okay, so let's look at this code. First let's put the timer on the, First let's put the timer on the screen. So I don't have time to start up a new one. You already started your new one. So I'm just going to put it on my original, on the other program. Oops, here it is. I'm just going to put it here, but you're not supposed to put it on this program. You're supposed to put it on the, anyway, it's over here. You go to All Windows Forms, and you scroll down to Timer, and you just drag it on there. Now, the thing is, it doesn't show up on the screen because it's not really something that's supposed to be visible on the form. But it's still there, and if you want to access its properties, you just click down here. Okay, and then you can see its properties over here. And here the interval is set to 100, but that's read in milliseconds. So 100 milliseconds means 1/10 of a second. Right? But you could change that, but we're going to leave it at 100, which means every 1/10 of a second. Okay? So you do that, and then you go to then you double click on it, you double click on this, and you'll get this, private sub timer tick, right? And then that's where you have to put your new code. And I said you have to put in 3 lines, one for label 1, one for label 2, and one for label 3. And what do you want to fill into label 1? You want to use the RAND function. But unfortunately, the RAND function, as you just saw in Excel, doesn't generate a number between 0 and 10. And also it has all these decimal points, which we don't want on our slot machine, right? I don't want to see the number 3.87 on, right? You just want to see 3, right? You just want to see 5 on the slot machine, right? So what do we have to do? We take RND and multiply it by 10. That gives us a number between 0 and 10. And then we put that inside, what's this function called? int, we put that inside int. What does int stand for? Integer, right? So it rounds it off, basically, cuts it off. So it gets rid of the decimals. Okay? And then we're going to have a nice little number, a nice integer in the slot, right? So we'll have 3 because we're doing it 3 for each one, and that's basically it. Okay? So I think what time do we finish? Oh, we still have time. Okay. So that's the idea. Any questions so far? So again, when the user clicks a button, what happens? That's called an event, right? But here, we're using something that's generating events automatically. But we still want to write an event handler for it. Otherwise, nothing's going to happen. There's no point in generating those events if we're not going to handle them in any way. So we write this event handler here, okay? And that's what we did here. And that's going to do it. Okay, now one thing is here, look at this property here. So I click on timer just once, and look at this property here. What's it called, this property called? Enabled. Okay, enabled, if it's not enabled, if it's false, it won't do anything. But what we're going to do is we're going to change it to true. Now, what does that mean in terms of our program? It means as soon as we open the program, the timer is going to start. And since we have the event handler in there, as soon as we open the program, the numbers are going to start spinning. Okay, so by default, it's going to start spinning, right, as we start. Okay, by default, it's going to run. Okay, then, what's the idea in this game? How do you get it to stop? You click the catch button. Catch means stop. What does catch do? What's one thing that it's going to do? It's going to stop the timer. So it's going to set the timer property enabled to false. Okay, so that's one thing you have to do in the catch function, right? In the catch event handler. Okay, and then there's one more thing you have to do. So one thing you have to do is stop you don't want the numbers to keep spinning when you click catch. So you have to set the enabled property of the timer to false. Okay, but that's not the end of the game. If you just did that, it would be not so interesting. Maybe that's enough, but that's not what we're doing, right? We're supposed to give what? A prize if they get what? If they get a match. So we have to figure out some code to decide whether there's a match or not. And that also has to be in the catch event handler, the catch button event handler, right? So it's pretty complicated actually, but let's look at it. So here's part of what we need to do, right? Now please don't tell me that that's still running. Good. Okay, do you see what I said? For the catch event handler, what did we do? Timer 1.enabled equal to false to stop the timer from running, right? But that's not the end of the game, literally. That's not the end. We want something else to happen also. What? So we're going to put in this first of all. We're going to enter this into our program, but we're going to set its visible property. See this property here? There's a so-called visible property for this picture box. This picture box is going to contain the picture of the coin, but it has a visible property. And what do we set it to initially? False. What does that mean? That means when we start the game, this picture won't be visible. Okay? But what do we want to happen if there's a match? We want to set this to true. But, okay, so now so that we're going to set that to true under a certain circumstance. Now we have to write the code for if there's a match. now we have to write the code for, quote unquote, if there's a match. Right? How's that work? Here it is. This and this, these two, or actually 1, 2, and 3. This is the code for if there's a match. So the first line is just, usually you have to, what we call declare the variables first. You have to, when you, so we're gonna define 3 variables, just like math variables. X, Y, and Z, in fact, they would call them like math variables. Okay, and you just have to say what type they are. And these are integers, so we do that like this. So it just says, dim stands for dimension. And sometimes, when we talk about 2 dimensions here, this is 2 dimensions, right? The x dimension and the y dimension. So dimension is another word for variable. So they use dim, I don't know why. Okay, so they use dim x, y, z to declare 3 variables. Okay, that's simple. Now, what do we assign these x, y, and z to be? In part 2, what do we assign x to be? The value that's currently in label 1. Remember, label 1 is changing constantly. But when we click the catch, it stops. And then we get the value that's in label 1, and we put that in x. And what does y get? The value that's currently in label 2. And what does z get? The value that's currently in label 3. Okay, so now x, y, and z are set like that. Now, again, what are we trying to do? We're trying to decide whether we have a match or not, right? And if we do, what do we want to happen again? If we have a match, we want to show the picture, right, which means like make that property visible, and we want to beep. Okay? Okay, so that's what we're going to do, but what's the decision? It's going to be an if statement. It's going to say, if something is true, then. That's called an if statement in programming. So what is it? If what? If one thing or another thing or another thing, it says. Right? So if any one of those conditions is true, then we're going to give them the prize. What is it? What are the conditions? If x equals y means the first label equals the second label, or x equals z, or y equals z. Then, blah, blah, blah. Okay, so that's the syntax. You see now the syntax of an if statement. Okay, you see how to write an if statement, and you see how to use the or concept there. Okay, now we should study that, maybe carefully, but it's just showing you here. Okay, and it's pretty obvious how it works, but it might be good to discuss it, just in general. But anyway, we're just using it here. Okay? So what you do is you say, you have to follow that syntax. You have to put the parentheses where they are, you have to put the ors where they are, you have to put the then where it is, and you can put other stuff underneath it like you have, and then you have to write and if at the end. Now, Visual Basic will probably write the and if for you without you doing it. I'm sorry, Visual Studio will probably write the and if for you. Okay? But you have to make sure that it's there, but it will be there. Yes?
If you put or, the rule of the slot machine is every 3 labels should be the same, but if you put or.
Yeah, this game is set so that you can win more easily. Because otherwise, to test it, you have to test it like 1,000 times to get it to get lucky. Right? No, it doesn't matter. You can make your game like you want. Okay? You could write different rules. Okay? But anyway, if you write a strict one, like all of them have to be equal, you can think about how to do that. But if you do that, then imagine trying to test it to see if it's working or not. You won't get, you test it, no match. You test it again, no match. You have to test it like 10,000 or like 100 or 200 times maybe before you can actually get a match, right? So that's not very much fun. So here we make it a little less strict, right? So if any two labels are equal, it'll give you a match. Okay? All right, now, does he also, I don't think he ever talks about, he does talk about, okay, we have just a few seconds left, so I'll just mention this last part, which is counting or keeping account of the number of wins. Okay? Now this is a little tricky because, let me explain one thing. Whenever you create a variable, if you create that variable inside a subroutine, or in other words, inside here, this is called a subroutine here, this thing, inside our event handler. Our event handlers are subroutines, so inside the event handler, or inside a subroutine, whenever you create variables in there, as soon as that subroutine is finished running, those variables disappear. They're gone. They're not in memory anymore. You can't read them anymore. They're just, the computer loses track of them. Okay? So if you had a counter that was counting how many wins, and you define, so you're going to store the number of wins in a counter here. If this counter was declared here inside the subroutine, it would keep forgetting what it was equal to. It would never keep track of it. So where do we have to define the counter? Outside of any subroutine. So up at the top. So if it's defined outside of any subroutine, it's always going to be there as long as the form is running. If you close down the form, it's going to be gone. But as long as the form is running, it'll keep track of the number of wins. So what we do is we define a variable here, and you have to use it. He uses this private and all this other stuff. But anyway, basically, we're just defining a variable here, and then remember, this is when we win, right? If the only time that the beep happens, the only time that the text says you win, the only time that the picture box.visible is true is when? If there's a match, right? And also, the only time that the counter gets incremented is when you win. Okay? So it gets incremented when you win, but it holds on to the value because it wasn't, these variables are going to disappear. As soon as we finish clicking the button, these will disappear basically. But since we defined counter up here, it won't disappear. So it'll hold on to the value that it gets and then increment it next time. Okay, now one other thing is that this doesn't make sense mathematically. This is computer talk, computer programming talk, but it doesn't make sense mathematically, right? We never say that x equals x plus 1, right? We don't write that. Right? There's no solution to that, right? But this doesn't mean equals. This means take this value and put it in there. It doesn't mean equals. In fact, to write equals, you have to write like that. Okay? Usually. But you didn't have to do it in the... Anyway, let's see. I'm not sure about that, actually. Most programming languages, you need to write that to mean equals. This doesn't mean equals. Okay? It means take this and put it in there. Okay? Okay, well, that's all we have time for. So you have to do both of these. Make sure, if you can, that you understand what I said about events, about where to put this counter variable, why you need to put it above, not inside. So you can go back and review this video. And also about tick events, and also about setting the picture box .visible property to true. Okay, those are all important concepts to make sure you know.
So should we then put 2 homework in 1 folder or 2 folders?
So in terms of
separate